For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below. Let H be the set of all vectors of this form. Find a vector V in R3. So R3 is a three-dimensional space of all real numbers. Remember that R2 is just your plain ordinary XY coordinate plane. Why R2? Because there's two variables. Any coordinate is just X and Y, or XY. So in a three-dimensional vector space, instead of just X and Y, now you have Z, X, and Y, and when you plot a coordinate, it's three variables, X, Y, and Z, which is why this is the three-dimensional space of all real numbers. And it's a vector space because you could just treat any points as vectors, like so. So we're dealing with the three-dimensional space of all real numbers, just the 3D coordinate plane, and we're trying to find a vector in this plane such that I take all of the linear combinations of that vector, and it's going to generate H, so H being my subset. So H is just a set of all vectors of this form. So H can just be something like this. It's just something inside a vector space. That's the definition of a subset. And all it's really saying is define H as a span of a vector. And so they're giving you this. So I like to think of it as factoring out a t. So to get from t to t, well, you would just multiply by 1. To get from t to 3t, you would multiply by 3. And then to get from t to 2t, you would multiply by 2. And then this here is the vector that you're going to plug in right here. So you would just say that H is equal to all of the linear combinations of this vector. Now we can say that H is a subspace of R3 because we know that if we can define a subset as a span of one vector or more, then by the theorem that I introduced in the last video, so if you haven't watched that, it's linked in the description box below under Sarai Studies in linear algebra section. That theorem simply says that a span is a subspace, but on an exam you would explicitly write the theorem. So it says that if you have some vectors v1 to vn, so you just have some vectors. So right now it's just a collection of vectors, it's just a subset, something inside your vector space. So in vector space V, then all of the linear combination of these vectors is a subspace of V. So what's another word for all of the linear combinations? Span. So that's where the span comes from. So obviously I don't know what H actually looks like, so it's not like it's a circle. It's just for an example, but that's the idea. So by the theorem above, if we can define H as a span of vector or vectors, then it is a subspace of V. And that's it for this video. I'll see you in the next.